How many boxes are an inch on engineering paper? 5. So if every box is 2 feet, 1 inch is 10 feet. So you're using a scale of 1 inch is equal to 10 feet. So write the scale of 1 inch is equal to 10 feet on your paper. And now you want to find these points. You have 4.8, this is a cut, right? So if it's cut, is the existing ground surface going to be above or below the road? Is the existing ground surface going to be above or below? Above, because it's cut. So you have to go 17.2 out from the center of the road on the X, and you got to go up 4.8. And then you're going to go out 20.2 on the right and 6.8 up. So draw it first. Okay, this is what it should look like approximately. drew my little slopes. Okay, I don't think you need to do the math, because we've done a lot of those problems already. What I would rather us spend the time on, because we only have an hour left, is just to make sure that you can draw it appropriately. So let's take a look at this over here.
Do you want
So
us
said
to
the-
label all the green spots?
Say it again.
Do you want us to label what you have
Well,
in
you're
green?
gonna draw it to scale, so you don't need to, okay? So first that was given to start with the base, it's 20 feet, so 20. This is the center, so this right here is, where's this point? This is my origin, right? So that's 0, 0. The origin is always on the center of the road base. I put 10 out, and then I measured out 7.2 and up 4.8, and located this point, and then I went out 20.2 and up 6.8, and I found this point, and then this point was on the center line of the road, but it was above it 5.9. I put C's for all cuts, because it's a cut thing. Okay? So when I go to do the math, when I go to do the double area method, I also need these two coordinates, right? And then I'm gonna write them, and I'm gonna make sure I put the negatives in. Okay, let's look at the next, another one. So the second one is very similar.
Joanne,
Yeah,
I've never been there, but drawing to scale, I feel like the embankment doesn't meet the point.
it will, if you drew it to scale appropriately. Yeah, so I'm glad you brought up the embankment part. I made these problems up. I made sure that the embankment I set went exactly to this point. Normally, when you survey, you go far out, right? You go far out, and then wherever that embankment hits, that's the points you need for the area. But here I made them fall right on it. So it may be because you're not drawing it to scale properly. Make that Y value scale and the X the same. I can look at it at the end. Okay? Okay. Let's look at another one. Okay. We're, see 3 and 4, I'll give you the answers to 3 and 4. Part of it is cut and part of it is fill. I would just not, you don't have to do it. Let's look at 5 now. Wait, first. Look at 1 to 4. What do you see in front of the numerator? C or F, meaning cut or fill. What do you notice on number 5? It doesn't have a cut or fill. And does it make sense that somebody's going to cut 125 feet down? No. So this can't be a cut coordinate. So let's take a look at it. It says a base is 20 feet, 10, 10. With an elevation of 120. The elevation of the base is 120 feet. So what do you think these numbers are? Elevations. So what is this really? Do we know if it's cut or fill yet? Maybe, no, we don't. If the base is 120 and we're getting elevations above that, is this a cut or a fill problem? Cut. So can I, what should this, if it was written in the appropriate coordinates, this would be cut what? 5 over 20. What's this? Cut 6 over 5. What's this? 5 over, what's this?
4, 10.
And this is?
Cut 5.
Okay.
Surveying the points.
No problem? So when they surveyed the points, they just figured out what the elevation is. They were coming from the benchmark. but we had to convert them to the way we represent coordinates in surveying in terms of its distance above the base or below the base. Does anybody have any questions on this? Ty? Do you
I
understand
was
this?
wondering why it's not filled, because if you have like 125, isn't it over?
Okay, so let's think about it. The elevation is 120, right?
Mm-hmm.
So here's the elevation is equal to 120 feet, right?
Right.
These points always represent the point that somebody surveyed. So this has to be the points that they surveyed, the existing ground surface. The existing ground surface, we got a 5, we got a 6, a 5, a 4, and a 5. This is where the surface of the ground is. If this is the surface of the ground, and this is where the road is, if you want to put the road in, you're going to have to cut all this.
Okay.
Okay? Okay. Let's look at 6. Don't you like this one? It's a little bit of a puzzle. What?
On that one, they're not completing.
Number 6?
Or 5. They're not completing the circuit, are they? They just happen to cut the same exact amount.
They did, because again, I made sure that the 2 to 1 hits these points. So it is a circuit.
Oh, they do. Okay.
Yeah, they cross exactly. But the next one will be different. Okay, let's read this one. So, can these numbers realistically be cut or filled? Yeah, realistically they can, but what are they missing? There's no C or Fs. They do not, they're not giving you a C or an F, which means this is not the vertical distance, this is not the vertical distance above or below the roadbed. Because it is only when it's in standard notation does it represent the value, the numerator represents the value above or below the roadbed. Okay? So because there's no C or F there, what does that mean? This is not referenced to the roadbed. This is not referenced to the roadbed. It's not the vertical distance above or below the roadbed. And we figured this out, that this must be an elevation. Well, this one could be an elevation. Maybe we're right next to the water. I don't know. But I certainly know it's not the vertical distance above or below the roadbed. So I should say not. So we have to figure out what these numbers represent.
Robert.
Yes.
So let's read it. Field notes given with a height of instrument. So you have a height of instrument of 1254. 40-foot wide level roadbed, 2020. I drew that line already. With cut slopes. Ah, they tell us cut. How nice. Of 2 to 1 is the embankment, and a subgrade elevation is 1239. So that means that my road goes out what? 20 here, and it goes out 20 here. This is the roadbed, also called subgrade roadbed. And what did they say the elevation is at the roadbed? 1239.5 feet. They're telling you that the height of instrument is this. How do you calculate a height of instrument? Remember leveling? In leveling, what did we start knowing? We knew the elevation of the benchmark. Then what did we do? We took a site, what was it called? Backsite or foresight? Backsite, and what did we do to the backsite? We added the backsite. And what did we get? Height of instrument. How do we get the new elevation? Take the height of instrument, subtract the foresight, and we get the new elevation. What are these things? What are all these numbers here? What do you think? Forsyths. Okay, let's go back. On number 5, the numerators, how did you know that these did not represent heights above or below the roadbed? There's no way in hell it could be because it's too big. And no CRF in front of it. So you had to figure out what it was, and when you read it, you realized, oh, these are elevations. How about here? No CRF in front. Does it represent the vertical distance above or below the roadbed? No, because there's no CRF. So we have to figure out what that number is. And when you read through here, if they're giving you the height of instrument, it means that they already figured out what the backside. They already figured out the backside. Right? So remember when we were lining up over there to do the cross section, and I was sighting? Like I sighted the back sight, right? I knew the elevation of the back of the benchmark. I sighted the backs. Sorry. Let me slow down. We were lined up out there on the road, on the cross section. I sighted the benchmark, and I knew its elevation, and I got its back sight, and now I knew the height of instrument where I was. And then I shot each one of you, and I got 4 sights. And because I knew the height of instrument, I subtract the foresight, and now I'm getting the new elevation. So let's just take this one right here. So how do I find out the elevation of that point? The height of instrument, and what do? Subtract 3.5, and I get 1251.30. So this is the elevation of this point. Am I done? No. What do I need to do now? Well, actually, what's good is, I mean, they told us it was a cut, but now confirm for me that it's actually a cut tie. I was given the subgrade, the road elevation of 1239, and I calculated that the elevation of this point right here is 1251. Show me where the road is with one arm, and with the other arm, show me where the existing ground is. What's the elevation of the road?
1251.
Subgrade elevation. The elevation of the road is 1239. And then where is this? What's the elevation of that? 1251. Where is it? Above it. So is it cut or fill? This is my road, and this is the soil. It's a cut. So now, how do I find the numerator? How do I find the numerator for this point? What am I going to do?
Subtract the road's elevation.
Right, so 1251.30 minus the elevation of the road. What does this come out to be? 1180? Is that right? 13.1. Yeah. Did I what? Did I do the
Sorry, no, never mind.
1251.30, 1239? I think it's right, right? So what is, then it's a cut, 1180 over, we still put the 50 in. So this point became this coordinate. Okay, so initially, the problems gave us what does this numerator represent? Because it's a C or an F? The vertical height above or below the road. But in these problems, they didn't give you that, and you know because they didn't put a C or F in front of it. So you have to convert it. Leaker question? No? Okay, so we're gonna pull us down. So what I want us to do is look at this, look at the syllabus. Yeah.
For the road bed.
Oh, right, you had the question, I'm sorry.
It's okay. For the road bed, length for.
Hang on a second, let's go. Hang on.
Given? The
What?
road bed length.
The length of the roadbed was always given on these problems. So 30-foot wide roadbed, so it means 15 feet this way, 15 feet that way. 30 feet wide. Here was 40-foot wide, 20 out, 20 out. This one was 20 feet, 10 out, 10 out. They always give it to you. That was your question before?
Is it pretty normal to say subgrade even if it's above grade?
Subgrade is always below where they put the asphalt,
Oh, okay.
you know, so we're talking about all soil here.
Okay.
We're not coming in and putting in asphalt.
Fair enough.
So we're always dealing with the elevation of the dirt. Okay. Okay, so. Okay, so our topic today was volume and earthwork, which we did, and the extra problems, which we started doing those extra problems. If you notice, the top of the page said extra problems. Discuss lab GPS, we're not gonna discuss that because Kelly's gonna teach the GPS that day. There's no need to talk about it now. So you have two homework assignments. One is the volume homework, which is on the web page, and then the extra problems, which actually might be on the web page too. We could look at, but let's look at it. But I wanted to point out then, because class 12 is when the topo assignment is due, this Saturday is the GPS lab, right? Right, so the only thing, there's nothing due on Saturday. Instead, the topo lab's due Monday, so it's a week from today. You have the volume homework to do, the extra problems to do, and the field lab.